Итак, прежде чем мы будем продолжать, есть ли у вас какие-либо вопросы или идеи, или замечания? Если вы что-то подумали или придумали во время перевода? Нет? Ну хорошо. Там были блокноты. Итак, давайте продолжать. Во-первых, я вижу, что вы не берете эти флаеры, которые приглашают на конференцию, возможно, и потому что вы стесняетесь. Я их здесь оставлю поближе. Просто я хотел вам напомнить, что есть эти возможности, эти флаеры бесплатные. Берите, пожалуйста. Итак, разве что, вы не хотите идти на эту конференцию именно. Все-таки давайте перейдем к следующей части нашего разговора о миграции схемы даты и данных. То есть мы будем говорить о схеме, о структуре таблиц, о том, как проводить миграцию. И перенос данных, он, в принципе, будет зависеть от двух механизмов, о которых я уже сегодня рассказывал. Оффлайн-миграция, которая проводится во время даунтайма, и онлайн-миграция, которая проходит при даунтайме почти 0. Это две части, которые, в принципе, проработаны уже в других презентациях. Они представлены на конференциях Postgres. Поэтому я думаю, что вы вполне уже знакомы с этой темой. Во-первых, я хочу поговорить о стратегии переноса данных. Есть две возможности миграции. Та миграция, которая делается за один раз, или постоянная миграция. Это та миграция, когда вы все время улучшаете ваши скрипты, ваш код для того, чтобы данные передавались в постоянном режиме. Обе эти схемы реализуемы, возможно, но нам всегда, скорее всего, нужно будет работать на миграции одномоментной, потому что люди, которые работают на Oracle, хотят проводить миграцию на Oracle и не подходить, не возвращаться уже. Итак, как мы можем начать? Первый шаг почти всегда это использование foreign интерраптора FTW Oracle. Все эти FDW, о которых я уже рассказывал по Postgres, они позволяют передать источник данных и показывают, что это локальный источник баз данных. То есть вы сможете увидеть, что ваши Oracle базы данных могут переноситься в Postgres, вы можете переключаться между ними. Это на самом деле очень круто, потому что это позволяет вам переносить, импортировать чужие схемы. То есть вы в Postgres можете создать все таблицы, которые локально у вас находятся на удаленном хранилище. И это прекрасно, потому что это автоматическое конвертирование схемы, и мы можем увидеть данные с точки зрения Postgres. Здесь основной ключ — это использование тулзы под названием Ora2PG. И это, очень большой подход. То есть, скорее всего, вы будете его использовать, он уже вызрел, он уже хорошо тестирован, и есть документация соответствующая. Он находится в открытом доступе, он бесплатен, можно пожертвовать. То есть, если вы делаете какую-то миграцию, то вы можете автору перевести какую-либо денежку. И он, в принципе, хорошо работает. Ключевая ситуация здесь такая. Когда мы используем Ora2PG, конверсия схемы, и мы будем это говорить по всем видам миграции. Но ключевая фича здесь заключается в том, что вы должны создать схему для себя. Но потом, наверное, вы захотите конверсию изменить, настроить. Например, увидите, вот эта таблица, там номера сохраняются. Здесь есть примечания, но я точно знаю, максимальный размер данных будет тут 4 байта, допустим. Поэтому нужно это внести в Postgres. И вся эта настройка, вы всегда ее можете изменить попозже. Но вручную изменять такие настройки, это не круто. Потому что во время миграции вам нужно будет писать много раз это, вам нужно будет проводить тесты, вам нужно будет менять вещи. И, скорее всего, вы можете ошибиться, потому что вы можете забыть какой-то тип данных, и вам нужно будет постоянно начинать процесс заново. У вас будет, например, много различных тасков, но вам нужно это, короче, автоматизировать. И как это сделать? Это ora2pg конфигурация. В этой конфигурации можно много чего нести. Вы всегда будете в таком случае делать автоматически то, что вам нужно. И это ключ к повторяемой и поддерживаемой миграции, стратегии миграции. То есть мы можем настроить ora2pg для того, чтобы она делала то, что вы хотите, и работать. То есть вы можете начать с этого, настроить объекты и понимать и внести то, что вы хотите сделать с объектами. Я ничего не могу вам больше сказать, чем это сказано на веб-сайте, поэтому я приглашаю вас пройти на веб-сайт, прочитать, посмотреть все опции, и вы найдете то, что вам нужно. Он поддерживает все схемы, все функциональные триггеры, материализированные, все это доступно в Oracle. И для многих всегда есть альтернативы, если нет четкой первой опции. Например, ora2pg может вам показать то, что вам нужно для аппликации. Если вам нужно меньше,
it can generate code that will use the orafce functions. Remember orafce, the package that contains many Oracle-compatible functions. So you can instruct ora2pg to generate code that will require orafce. Or if you can change your application more, you can instruct not to do that and rely on bare Postgres. So it really depends on you and the options you choose for ora2pg. Now, when you do the data migration, which again is also ora2pg, very likely you will see this error. Anyone has seen this error in Oracle? It's quite common, right? So what happens here is that this is a significant difference in how Oracle and Postgres work. Postgres can basically hold a transaction open for as long as you want. Say you open a transaction, and you can keep it for days, no problem. Well, actually, yes, there is problem. That will prevent some mechanisms like vacuum from running. You'll accumulate bloat, and eventually your performance may start to decrease. But I mean, it's not the end of the world. Don't do that anyway. Don't open transactions for a long time unless you really need it. You need to do a query that is running for hours. But other than that, you're good to go. In Oracle, you can not do that, because Oracle uses a totally different mechanism for handling multi-version concurrency control. And with Oracle, there is a limited space for storing the changes that will allow you to make your database appear to be frozen on a given instant of time. So if you open a transaction for doing a query that be held for a long time, you may run out of reduce space. And that will cause an error in Oracle, which is this one, ora 01555, snapshot too old. So how do you fix this? Well, the way to fix this is to either augment this space, if you want. So when would you experience this error within an Oracle to Postgres migration process? While migrating the data. To migrate the data, you basically need to take a snapshot of the database and dump the data. And in this process of dumping the data, you may run out of this reduced space, right? This is going to happen most likely on the live migrations, but you may also experience on non-live migrations. And if it happens, it becomes problematic, because if you cannot make more disk space for this, the only option left that you have is to speed up the dump process, dumping the data. Again, with ora2pg, but how do you speed up the process? So there's two things you can do within ora2pg or in general with any other tool to speed up this process. and both involve running in parallel. The first level is what we call inter-table parallelism, and basically implies that we will use several processes in parallel to dump different tables in parallel. This most likely will, if you have enough cores and enough good disk I/O subsystem, this will improve performance, and you'll be able to dump all the tables faster, and then the chance of facing this error will be less. Now, typically databases have a few very large tables and many smaller other tables. And if you have specifically a very large table, that will dominate the total time of the migration. So while inter-table parallelism will provide you some benefits, it may not be enough. If one table is 40% of the database, you will basically cut by 2 the time by using inter-table parallelism. So the next step is intra-table parallelism, which is to instruct Ora to PG to use several processes to also dump a table. And it will split the table in chunks and do parallel dumping of those chunks of the table with this in several threads in parallel. This has the advantage that will definitely cut the time to dump the table. But at the same time, it will create not necessarily ordered rows on the destination, which is not necessarily bad because in general, rows are not ordered, specifically to a physical order, but it can also cause some surprises. But this is sometimes necessary, especially in any case, even if you're not facing this Ora 01555 error, you might want to dump all your data as fast as possible. You want to incur in the minimum downtime possible for your users, for your customers. And dumping tables in parallel with both inter-table parallelism and intra-table parallelism is almost necessary. If someone will tell you that you need to stop your production database for 16 hours, it's very likely to be unacceptable. If you say I can cut that down to 2 hours and 30 minutes, maybe yes, maybe no, right? But you still have a chance there. So it really depends on the environment, the customer, how important it is to keep this system alive in production. But in general, this is very, very important. And this is not an easy task. You will need to understand, you will need to do benchmarks, you will need to do timing, and at the end of the day, you will come up with a conclusion of basically the biggest tables will do intra-table parallelism. The medium-sized tables, you'll do inter-table parallelism, which means you will process them in parallel, but not necessarily split them into smaller chunks. And the smaller tables, you can do serially because they are not going to change almost anything. And the overhead of making this scheme could be complicated. So basically, I recommend always to split into these 3 categories. The intra-table parallelism, the biggest ones, the inter-table parallelism, and the no parallelism. And then you will speed up the time, typically from, again, I remember last migration, the serial scheme was more than 10 hours, and with this strategy, we cut it down to less than 2 for an offline migration. So it is very important, very, very important. All right, this is for offline migration. Let's talk a little bit about live data migration, because this is the most important topic I wanted to bring here to the table. How do you do a migration without downtime? So just taking on this last example, I mentioned that you can cut down a migration for example, to less than 2 hours. This was a few terabyte database. But what if, the production system cannot stop for 2 hours? And it's hard to optimize this more. And even if you put a really, really fast machine on the destination, the old machine is what it is, right? You cannot upgrade the hardware also live. So what do? The only option is to find a way of moving the data over continuously, non-stop. And at some point, you'll do the cut over. And the cut over means I will stop writing to the origin database, wait until the data is fully replicated to the destination, and then bring it up. That's why it's called near zero downtime, because there's almost no downtime, just the replication lag between one system and another one. So how this works and how can we use this with, from Oracle to Postgres. Because actually, from Postgres to Postgres is kind of doable. There's logical replication built into Postgres 10 or higher. There's logical decoding, which is a base for this technique since Postgres 9.4. It exists from a long time in MySQL, but how do we do this from Oracle to Postgres? So let's start by understanding actually how this mechanism works, the name of this technique, and then we'll go into some ideas for tools. So the basic principle is, I want a migration without downtime, right? So all the solutions that imply a dump of the data and then restore of the data, we cannot use them, like Ora 2PG, or like taking a dump in Oracle's, taking a CSV, importing the CSV into Postgres. Those tools will not work if no downtime is acceptable, right? There's other options, and there's many commercial tools that claim to support this functionality, but they work on an ETL manner. ETL as in extract, transform, unload. And the ETL, the way ETL works is mostly in batches. So they scan ranges of a table and then scan for the changes happening there and ship them in batches to the destination. This could more or less work, except that it is not very performant, so it will put some extra pressure on the source database, sometimes unacceptable extra pressure. And second, and more important, it will require to create extra columns on all the tables of the source database, typically a column called created add, another one updated add, which is basically the internal mechanism it has to keep track of which rows have been changed since last time, and then find those changes and push it back to the destination database. And that's very invasive. I'll need to change my DDL, extra storage, and extra performance involved in the source database may not work, and actually doesn't work in many situations. So the only option left is to use a technique called CDC, or change data capture, which is very well known, probably you're very familiar with the term, and it involves capturing, as the name implies, the changes that are happening in the source database and somehow shipping them over to the destination and applying them. Conceptually, it's very simple. If I were able to tell the source database, hey, please give me kind of a stream of the changes that happen in your database, basically every insert, every update, every delete that happens on the source database. If you could give me like a stream of those changes, and I would apply them on the destination in the same order as they happened, I'll be able to reproduce the same state on the destination system. And eventually, I will end up with exactly the same data on both systems. So this is how it works, and this is the technique that needs to be involved for this kind of live data migration. So in order to understand how CDC works, I need to find a scheme where there's two phases. And these two phases are separated by a point in time, which is arbitrary. I just need to pick it. It needs to be one point. And before this point will be what is called the phase one. After that point will be the phase two. So this point, again, is just an arbitrary point in time. And in Oracle, I can select it very easily, just doing a query to get what is called the SCN, or the sequence commit number. It's just similar to Postgres LSN, right? So in Postgres, in Oracle, all the history of the database has like a counter that is monotonically increasing, right? A number that is growing, basically, continuously. So I'll just pick a point in the history of the database, and I will get that number, which in Oracle is called the SCN. Now, the two phases are, and let me start with the second one. Starting from this point, from this SCN, I will ask Oracle, please give me all the changes that are happening on the database since this instant in time, this commit number. And Oracle has a mechanism, actually has, there are several mechanisms, but Oracle has a mechanism that will give you every insert, every update, every delete. Actually gives you much more than that, but let's simplify. It will give you a stream of those changes since that commit number. right, since that SCN. So from that point on, I'll get all the state changes that happen to the database since that initial state. So I select this SCN, and then I allow this stream, this change recording phase 2. But now I have the changes, but I cannot apply them on the destination because the destination is empty and the state doesn't match yet, right? So I need to first perform another operation, which is the phase 1 or the backfill, which is, okay, please go back to Oracle database and dump me all the data, show me all the data that is in Oracle database exactly as it was, in other words, frozen at that same instant of time. And Oracle has this capability, which is called a flashback query, which means a query in the past. So I want to query tables as exactly as they were at that precise instant of time. So if I go back to Oracle and say, I take that same SCN, and I say, do a select star from table as of SCN and the number. That will give you a dump of that table exactly the state it was at this SCN. So now I can see how these two phases work. First of all, I select the SCN, and I start recording the changes that happen to the database. But I don't apply them yet. Now I go to phase 1 and I do the backfill. The backfill is basically for every table, and you can even script that very simple. For every table in a list of tables, do select a star from table as of SCN, the number, and you insert this into Postgres. It's just mere inserts. You're doing a select, right? You transform the data into typically a copy in Postgres because it's much more efficient, and you backfill the whole database. While this process is happening, the version of the data you see from Oracle is not changing at all, even though if it's really changing, because Oracle is keeping a frozen version for you, it's keeping a snapshot at this SCN. You can dump these tables in parallel. You can do intra-table parallelism. You can do inter-table parallelism. The same techniques that I described just before, you can use them here. Just do select, and then you append the where ID within this range. If you want to do inter-table parallelism, what do you want to do? Intra-table parallelism, right? Once you have finished to backfill the destination database, then you're ready to push the button and start applying the changes that were being queued as part of this phase 2. So now I will release all those changes that were being queued, all those inserts, updates, deletes, and then I apply them to the destination database, in order, of course. And now I can do that because I already reproduced the same state. So once I have done I finished the backfill, the destination database is exactly at the same state at the SCN, which I captured at the beginning. So now I get all the inserts or the updates or the deletes that were happening in the source database. I apply them in order, and now I continue doing this. It will take some time to catch up at the beginning, to apply all these changes that were queued, and at some point it will catch up eventually, right? And so source, destination, and source and destination database will have the same content. And every new change that happens on the origin will get automatically propagated to the destination. And I will keep this running for all the time until I want to stop this process. There might be a replication lag. Typically, it's in the order of a few seconds. So any insert, update, or delete that happens in Oracle will go back to Postgres. And this is how this mechanism works. And that's how you can do a live data migration. Because now the cutover is very simple. I stop the traffic in Oracle so that no more changes are happening. I wait until the last change is propagated to Postgres, and then I can turn Postgres on. I can point the new applications to Postgres, and I'm good to go. But that's not the only benefit. The other benefit of the CDC mechanism is that you can test the destination with live data. You can start doing queries on Postgres. You can, even if you want, you can write to Postgres. You will ruin the synchronization at some point, but you throw it away and you start again the process. And it's typical on these scenarios that you may run the CDC process for weeks or even months by testing the destination database with live data, with live traffic. It's basically a way of reproducing also the traffic you have, not the select, but at least the changes on the source to the destination. And you can run performance benchmarks on that. And it's quite handy. It's almost necessary to do a good migration. Now, what do you do with the DDL? The DDL is a little bit more tricky. Some CDC-based systems support also shipping the DDL, some don't, right? So, but the key is that you should disallow DDL changes. You know, you're in the middle of migration. It's not the time to start changing database structure. So, I mean, we would typically prohibit this. It's like, sorry. While the migration happens, don't change the DDL. Otherwise, it's impossible, right? But before that, this phase one, or this backfill, or the initial data load, I want to call it that way, it's performance critical at some point. First of all, because in Oracle, you may face this Aura 555 that I mentioned before, because you're effectively freezing the database. You may run out of disk, redo disk space. So you need to do this fast. In order to do this fast, it's better also on the destination to drop all the constraints and all the indexes. You know the data is already valid. You don't need to validate the data again. The indexes, is better to create them in a bulk fashion. So basically, what you do is, before this initial data load, you drop all the constraints, the foreign keys, and the indexes. You script, of course, all these. So you have the original schema that you generated with some tool like Ora2PG. Then you have a script to drop all the constraints. And of course, after the initial data load has finished, you can recreate the constraints and the indexes. Because then the changes that are happening during this phase two, the CDC itself, they will catch up at some point. Now it's not that much performance critical. It can take days to catch up. It doesn't matter. You'll do the cutover later. But your database is online. You never stop the origin database. You will not run any more of this reduced space. And so you can take some time to create all this. But you don't want to recreate an index during the cutover time after everything is finished, because that could take even hours. So you generate this in parallel. And also, it's recommended to create like a temporal table that I call it a tombstone. And a tombstone is just a dummy table you create to signal the end of the process. Because all the transactions are written in order. When you do the cutover, you're going to cut the traffic to the source database. And you need to wait until all data has been replicated to the destination. But how do you know that all the data has been replicated? I mean, you may know, depending on your domain, maybe you know exactly where data is being written to, right? But in general, because the data always flows in order, just create a tombstone table, and when there's warranted, there's no more traffic coming to the source database, just insert something, say, I'm finished. And when you see this appear in the destination, you know that effectively everything is finished. Very simple. Now, life is not that easy. You need to manage the sequences separately. Basically, typical CDC systems will not propagate the sequence value, but it's very simple. You just need to script this a little bit, so when you're in the cutover phase, when there's no more change and is happening to the source destination, look at the value of the sequences and script to alter the sequences in Postgres to set them to the appropriate value, the next one. Actually, what I typically like to do is instead of setting up the sequence value to exactly the next one that was going to happen, I round that number up to the next rounded number, full of zeros, one full of zeros, so that I know exactly when I started inserting new rows in Postgres. Might also be helpful for some forensics if something went wrong. What else? How do we do all this? This technique, this CDC, all these things that I have mentioned. Is there any tool? What tool does this? Well, good and bad news. The good news is that there's one tool that does this and works very well. And it's called Oracle GoldenGate. And yeah, it starts with Oracle, which means that this is a product by Oracle. And this means that you need to pay for it. And it's not cheap. It costs list price, $17,000 per core. And you need a few cores for this migration. So maybe you're going to get off of Oracle, but you're going to pay the last bit. right? GoldenGate is a very generic tool. It can support, is very advanced tool, very advanced. Supports very complex scenarios, cascading topologies, replication from heterogeneous sources and destinations, bidirectional replication with conflict resolution, in which, by the way, I don't believe very much, but it's supported. Supports many, many things. And since recent versions, supports Postgres as a destination. And we've used it, for example, the Blackberry migration, I'll explain you later, and works well, very well. But it's from Oracle. So basically, unless you have a site-wide license where you can use any Oracle product for free because you're already paying many millions to Oracle per year, it is not usually an available option. We had one customer that wanted to do this migration like crazy. And when we captured the requirements, they told us that the maximum allowable downtime was 1 hour, and for the business continuity. And we timed with Ora2PG using all the most complex scenarios of intertable parallelism and intratable parallelism, and the best we could get was 1 hour 45 minutes, not matching their business goals, right? And so we said, let's use GoldenGate. And this is the cost. I'm sure you can negotiate the price, get it down to maybe 50,000, I don't know, something like this. And it was a big company. They were earning a lot of money, and they said, we don't want to pay Oracle a cent more. We will take 1 hour 45 downtime. And they did it. When some people want to get off of Oracle, they really want to get off of Oracle. So, your choice, not mine. So, now, this is the beautiful part. Now, what is the bad part, or what are the gotchas about GoldenGate? The first one is that it is an PITA to configure. It is real big pain to configure. I would lie if I tell you that it costs less than 2 weeks of dedicated staff member to configure GoldenGate and get it running, unless you're already a certified GoldenGate mega super hyper expert. It is unbelievably complex, unbelievably cumbersome, unbelievably chatty, very hard to automate. We end up automating GoldenGate, but it was crazy stuff. And documentation is very poor, especially documentation for Oracle to Postgres migrations is almost non-existent. And it's almost focused on offline migrations, something which you could do with Ora2PG. For online migrations, there's almost no documentation, and the only few documentation that there is not consistent. It's not replicating your data correctly. It's involving data loss. So it is a pain, right? So just for the Blackberry case, the manual on how to configure GoldenGate was 12 pages. To configure GoldenGate to do this process. You can imagine the complexity involved. But, again, it works. And actually, it works very well. It was also even needed to make some changes back to the DDL in Postgres to make GoldenGate work, because it uses a driver which is based on ODBC under the hood, which has some problems with some timestamps. So, a lot of weird stuff can happen. But, again, as I said, it works, right? So, just to give you an overview of a little bit of how it works, first of all, you need to find this synchronization point. And then you're going to configure 2 things for GoldenGate totally separate: the initial data load and the stream capture, the change data capture. And GoldenGate doesn't care if you don't synchronize them correctly. You can do the initial load here and do the stream changes here with some part of overlapping. If that breaks, it's your problem. So it's actually very hackish how you made the initial data load for Postgres, because you really, from Oracle, you really need to do this as of SCN as part of a specific query in a command in the config file, because it doesn't do this by default. It's very strange. But it's how it is. This is a simple example of part of the configuration of scripts. These ones are like the smallest set of configuration that you may need at the end. But basically, this is how you specify this as of SCN. It's like a hack, because you need to say, hey, get all the information from this table and add these to the query you're generating dynamically. And you need to replace, this is a config file, you need to replace this dynamically with the SCN you have captured, which will, of course, change from time to time. Has a lot of oddities. For example, the logs and the capture data, it stores on a directory, and then you see there's 2 letters there. We'll generate file names, which is 2 letters plus 6 digits. And you cannot put more than 2 letters there because it cannot support more than 8 letters on the file name. It's like program for DOS or something like that, I don't know. It's very strange, but works very well. So, are there any other options other than GoldenGate? Yes. So first of all, there is Amazon DMS. I already mentioned it here, the database migration service. From a purpose perspective, is quite similar to GoldenGate. Unfortunately, not all the stories I hear about DMS are good. Actually, I would say quite the opposite. And it's only valid if either your source or your destination is in Amazon. Other than that, it theoretically works. There's a few other commercial tools out there, like dbvisit or Attenuity. Both are tools that are very generic also. They support many regions and many destinations. And in most cases, Postgres is quite recent addition, which means is in many cases not working very well. We actually tried dbvisit for another customer who didn't want to pay to Oracle, and didn't work very well for us, unfortunately. There were some bugs there. Maybe as of today it's fixed, but from a licensing perspective, it was significantly cheaper than Oracle GoldenGate. So, could be an option. And of course, I always like open source, I always like ideas. You can also build your own solution. It's not that hard. Well, it is, but theoretically you can do that. Oracle has 2 ways of capturing. So the initial data load is very simple. Anyone could do that. Select a start from table, as of SCN, whatever, you're done, initial data load. For the capture part, the change data capture part, there's 2 options in Oracle. One is to use an interface which you can access from SQL, which is called LogMiner. And if you access the LogMiner interface, you can see all the changes in order and the SQL statement that represent those changes. So if you basically query this and transport that to the destination system, you may be able to reproduce a CDC system. But it's also a bit slower. And the other option is just to take the Oracle binary logs, the redo logs, and parse them. They're binary files with a very complicated data structure, and it's not documented, it's proprietary, but some people have done it, so could be done. Actually, DMS, Amazon DMS did that, so you can do that. And last but not least, let's not forget about something we call the rollback mechanism. Rollback not as in a transaction, as in the whole process. What happens if I do the whole migration, everything works well, I do the cutover, and we're live. We switch all the traffic to Postgres. It was tested before. Thanks to the CDC and the live migration, I was testing this for months. I did performance benchmarks. All went well. I decided to go, and now I open the doors in Postgres. And I start receiving changes in Postgres. And suddenly, something breaks. Suddenly, you realize there was a bug, and you need to go back to Oracle. At least transiently, right? It's not going to be permanent, but you need to go back to Oracle. But how you do that? Because you already open the doors in Postgres, there's already changes in Postgres. Data has been modified. If you go back to Oracle, you will lose data. Well, that's one option. You're anyway in a kind of emergency situation, but you should plan better than that. And so the rollback mechanism is, okay, let's do something similar. Both databases are synchronized on an initial state, which is the same, right? Which is the last change to the database state that came through Oracle. They're synchronized on this state. What if I start recording the changes after the cutover in Postgres and apply them back to Oracle? Something like I do in phase 2. Because the original state is already given, right? So I just need this flow of changes back to Oracle. So if I do this, I may be able to switch back to Oracle in any time if there is an emergency. How do I do this? The same story, CDC. Good news, this is very easy to do with Postgres. Postgres, since version 9.4, includes a mechanism called logical decoding, and logical decoding allows you to capture all these changes happening to Postgres. And actually, you have a command line client, which comes with Postgres, which is called PGReceiveLogical, which will connect to this stream of changes that Postgres emits and dump them to a file. If you use Postgres supports for these output plugins, and one of those is called raw decoder, and raw decoder will dump these changes as in SQL format. So if you use PGReceiveLogical with the raw decoder plugin connecting to the Postgres logical decoding stream, you would be able to dump into a file in SQL format all the changes that happen to Postgres. Then the only thing that you need to do is write a parser for this SQL file, because you need to change the syntax because, for example, timestamps will not insert in Oracle. You write a parser, parse this file, transform the SQL, generate the correct Oracle SQL, and then, yes, this file you can insert back into Oracle. Then you can do two options: to insert it all the time continuously, in which case you will need an extra software to process this on a stream and also inject that into Oracle. Or if you need to do this as a part of an emergency, you will take some extra downtime and just generate everything into a file, copy the file over, apply the file with SQL Plus, and you're good to go. Anyway, the important part is that, yes, there is a way to develop a rollback mechanism. You should probably want to develop a rollback mechanism, and it's much simpler than the other way around. And you don't need GoldenGate for this. Questions? No questions? Okay. So then let's move over to other part of the migration, the PL/SQL part. This is typically the most significant on time-consuming part of an Oracle to Postgres migration, the store procedures. In Oracle land, it is very common to write a lot of business logic into the database in the form of store procedures. It is not uncommon to face projects where you have hundreds of thousands of lines of store procedures, and you need to take them over to Postgres, right? Or rewrite the whole app, which is probably desirable, but not everybody wants to do this, right? So you're stuck with needing to move the procedures. So let's understand a little bit how it works. Well, first of all, PL/SQL, it is a language inspired by Ada. How many of you program in Ada? Right, well, it is a language from some time ago, but it's still there. It is a little bit verbose, but it is otherwise it's quite complete language. I mean, I have nothing against. And so PL/SQL is kind of an Ada plus SQL, right? So it's two languages into one, and they integrate more or less. PGCSQL, Postgres kind of implementation, was modeled after Oracle's PL/SQL, but it's a subset of it. So this is another of the challenges. It's not that we need to port the code, it's that we actually need to fill in the gaps. And if some functionality is being used in PL/SQL that is not available in PGCSQL, then you need to work around that. What is more interesting is that the internal implementation is significantly different. PL/SQL mostly works like a database client, like you would do from a normal program, but that is embedded within the database. So there's like actually a communication, like a client-server communication going on between the PL/SQL code and the database server. PL/SQL, PGCSQL is actually a totally different beast, and it's something integrated with Postgres process. It runs in process and uses process resources and just executes the SQL as a normal query also. So it's a significant difference. This difference in what translates? Well, it basically translates into a significantly different performance profile. The Oracle PL/SQL, which to be honest is much more advanced, it is a compiled language. So Oracle compiles it internally to some bytecode called mcode and has an executor for this bytecode. And so operations in general are quite efficient. Specifically, if you're doing any numeric operations or any number crunching or any heavy processing, it's going to be very good at that. When you're actually accessing data, it is not that good because it needs to be over a kind of a communication channel. I mean, it's not terrible, but it is just a bit less optimal. PostgreSQL PGCSQL, because it all runs in process, is totally interpreted. So everything is going to basically, this is not exactly, but everything's like if it would be turned down into regular queries. And this interpretation process is slow, which means that for any number-intensive or processing-intensive operation, PL/PGCSQL is going to be significantly slower than Oracle. However, in terms of data access, it's going to be probably faster than Oracle. So you really need to understand what is the use case. And if you find in the process of porting an application from Oracle to Postgres, they're doing a lot of heavy number operations in PL/SQL, you might want to suggest to bring that back to the application instead of doing it in Postgres PL/PGCSQL. So PL/PGCSQL, to talk a little bit about this, as I mentioned before, it shares this space with the process. That means that it also uses the same data types, the same queries, everything, as I said before, will be turned into a kind of equivalent select expression, right? If you look into the language, it has like blocks within nested. You can nest blocks arbitrarily. And these in Postgres are implemented internally using subtransactions. Subtransactions can become expensive at some point. So be aware of this. Because it's very normal in Oracle to nest this heavily, that will turn into some performance problems in Postgres PL/PGCSQL. So you need to be aware of that. Even like any block that is started, like an exception. If you use exception, sometimes in Oracle exceptions are used for flow handling. And that will turn into a subtransaction in Postgres, will slow down the process a little bit. So don't abuse this. Okay, so basically, this already I already mentioned. It's also interesting to note that in Postgres, before Postgres 11, there was no support for subtransactions. This is also very common in Oracle PL/SQL to use subtransactions within a procedure to decide whether to actually call or not. In Postgres, this was not possible before Postgres 11. So as of today, if you're going to migrate an application from Oracle to Postgres that uses significantly stored procedures, you very likely want at least Postgres 11. Postgres 12 is not out there, so basically it means 11. Because you will be able to use this, to recall real Postgres procedures instead of what we have right now, which is functions. There is a slight differentiation between those. And within Postgres 11 procedures, you may create subtransactions. You can independently create them, commit them or roll them back. Because otherwise, they operate as a single entity. And if anything fails or you roll back part of it, it will roll back the whole stored procedure before 11. Right? So this is something you might want to take into account. But this is very good news. It's not perfect. There's still some use cases that are not supported. But for the most part, you can do subtransactions within a stored procedure. And that's very good. Okay, more differences between the languages. The modifiers for the functions. When you're creating a procedure in Postgres, following the Postgres syntax, you may specify how that procedure is affecting the data. Basically, these procedures can either change data or declare that they don't change data and just may change the output. They may return a different output if the source data changes because you're accessing a table in read-only, for example, or they're absolutely independent of the database data. And these modifiers, you need to, if you qualify your functions, you'll make getter performance because the planner may do all the tricks. If, for example, your data, your function, your code is not changing the tables. And the defaults are different in Oracle than Postgres. Oracle has the same concept, but the defaults are different. So you need to be aware of this. What else? Importantly, Oracle PL/SQL code structures the code into packages. Packages are kind of logical units of code where you define kind of the interface, which is the method names and return types and everything like the method signatures, and then you implement the body of those functions. That is nice, allows for some structuring of the code, but it's not really necessary on PL/SQL. So there's several options. One is to basically ignore the package structure and just move methods on a one-by-one basis. Or you can leverage Postgres use of schemas, where in Postgres a schema, in Oracle, the schema is a user. In Postgres, a schema is a namespace, a name under which you can group objects, which is basically what a package, if you think of it, more or less also is. So the technique involves basically moving these functions to the appropriate packages, schemas in Postgres, and to set up the permissions so that they could be executed by the parts that you want to execute. But that's not all. Packages also provide global variables. This concept does not exist on PGCL. You can have local variables to the methods, to the functions, but there's no support for global functions. So if you really need them, try to avoid them, because actually in general, global state belongs to other places like a database, and you have one very close when you're writing procedures. But if you really need some global state that is not going to be stored on disk, that is related to session, and you want to access it, you may simulate global variables with custom GUCs. GUCs are basically the parameters in the Postgres config file. And there's some existing parameters. You can also create your own parameters. This is permitted in Postgres. So if you do this, if you use custom parameters, those are effectively global variables. The only problem is that they are much slower to access than PL/SQL global variables. So this will also be a performance hit. But if you're really in global variables, is the way to go. Okay, just a few examples from real code that you see in place. So for example, the most important thing is that if the team who wrote the PL/SQL wrote carefully crafted code, yes, migration is going to be significantly easier. If they're doing crappy things that Oracle lets you do, you're going to have harder time. So for example, if someone wants to create a date, you can take sysdate. Sysdate is current date from Oracle, and then you convert this to a text using the 4 digits of the year, and then you say this is the 1st of January of this year. And that's how you can compose a year, where you actually don't care about the day of the month. You can imagine how prone to failure is this, right? A good way to do the same story is to use the trunc function, which extracts, in Postgres also called this trunc, extracts a field from a date. And that's what you expect to do. Another option, which is also related here to these implicit data type conversions that I was talking about before, is that you're expecting an integer value, and you obtain an integer value by basically converting it from a text which happens to have digits inside. This in Postgres will create an error. And the way you should do this is something like this, the same date trunc or extract function. So Postgres does not like this kind of conversions, and you may find these conversions in Oracle code or improper use of functions to generate arbitrary dates or something like that. There's a lot of conventions used in Oracle. So another one is not mentioned here, but Oracle does not support, like Postgres, minus infinity or plus infinity, which are very convenient placeholders for dates arbitrary in the past or arbitrary in the future. And so people rely on conventions, and then someone decides that the past is 1st of January of 1970, or those 1900, or there's to the year 2000, and then you'll find values there that nobody knows why they are there, and you need to handle them separately. Okay, so how do you really migrate code from PL SQL code to PL PGSQL, right? As I mentioned before, there are some tools like R2PG which will help you to understand the number of objects, the complexity, the lines of code, and will even translate part of the code automatically. But realistically, this is not enough. You're going to need manual intervention here. There's, at least as of today, there's no tool that will magically convert everything automatically. So you need to do it by hand. And basically, what drives this here is the lines of code. The more lines of code, the more work it's going to take. This is obvious, but it's important to understand. So the first thing that you should do is create a set of tests. Because the code you're going to write in PL PGSQL needs to behave the same as the original code, even if it was doing things wrong. So even if the original code, PL SQL code, was saying 1 + 1 = 3, your Postgres code needs to return 3 when you're asking 1 + 1, because otherwise your application will face changes, right? So how you do that? Create a set of tests in Postgres. You can use PLPG unit, which is a software to help you create unit tests for PLPG SQL code, and then you will test these outputs and make sure that the expected outputs matches the inputs, like in Oracle, and then you can start coding. And once you have done the coding, and here, yes, maybe you can rely on R2PG as a started point, but you're going to need to tweak that manually. Then, of course, you need to test it, no question, but also use the PL SQL check, which is another cool project by Pavel that allows you to at least detect not before runtime potential errors in your code. It's quite handy for this. Has two main modes, one called passive that will check every function before it gets called, and an active, which is explicit checks for the functions. I, of course, recommend the active one, because this one also requires to load a library in memory, but it will detect some errors which otherwise are going to be detected in runtime. And runtime is harder to test, and it will break things after the migration, and this is not very nice. So go with PL PGSQL check. And so last but not least, I want to show you, as I mentioned before, some ideas about a real example. Before that, any question, previous question before moving over? Don't be shy. No? Okay. Okay. Good.
From Oracle to Postgres happening. Is this a very common or very exceptional situation?
Okay, so you mean in general from the market, no? Who is demanding this? Okay, it's a very interesting question. So basically, some years ago, this was infrequent. Maybe I'm talking 4 or 5 years ago. There was the perception that Postgres was, yes, maybe an alternative to Oracle, was definitely cheaper, nobody questions that, was good database, but in general, the industry was agreeing that, Oracle is Oracle. Nobody got fired yet for choosing Oracle. If the decision makers are paying for Oracle, why bother, right? There's no one fired for selecting Oracle. You might get fired if you select Postgres and it fails, right? So this was the sentiment 4 years ago. However, there were some already, we were going through some process where some companies were moving to Postgres regardless. Because they knew Postgres well, they knew that Postgres could definitely be at the same level or better than Oracle, and were doing the migrations. As of today, I would say that this is a crazy tendency. Everybody, I mean not everybody, but significant part of the market is really wanting to move from Oracle. Most of them, they are very lost. They don't know how to do that. They're not experts in Postgres. They don't know how to do the migration. They don't even know that there's a possibility of doing a migration without downtime. And at the same time, Postgres awareness is significantly increasing. Postgres, as you probably know, has been named the database of the year for the last 2 years in a row. It is the most growing technology in the database, in the relational database field, actually in the general database field in terms of popularity. It has advanced significantly. Postgres 11 is a milestone in terms of porting PL SQL code to PL PGSQL because of these nested transactions. So I would say it is a very, very sweet moment for this. Oracle is increasing the pressure on their customers, either pushing them to move to Oracle Cloud or to increase the licensing. And I think this is a very, very good moment. And we're having a lot of requests, a lot of projects to migrate from Oracle to Postgres. Another question? This microphone, wait for, if you don't mind. Thank you.
During your talk, I felt that there is quite a lot of DBA's involvement into the migration, which is not applicable in my situation. Like we have Oracle DBAs and Postgres DBAs, two different universes, and all the migration will be done by developers like myself. So is that CDC change data capture technique is doable from developer point of view, from developer position?
No, I mean using data migration based on CDC is basically a DBA job only. It will require DBAs from both sides basically, mostly Oracle, because you need to change a lot of parameters in Oracle. You need to set up archive logging, supplemental logging. You need to review that the primary keys or unique keys are present in every table. There's a lot of things to do in Oracle land to prepare for a CDC, right? So you definitely need Oracle DBAs. Depending on the tool you're using, on the technique you're using, you probably also want some Postgres DBAs or stuff with Postgres DBA capabilities, because nevertheless you're inserting into Postgres, and it's really important, as I mentioned before, to tune Postgres. If you don't tune Postgres, performance is going to be bad, the migration is not going to be successful, and it's not easy to tune Postgres appropriately and to measure performance and to the testing stage while you're replicating to make sure that the queries are performing similarly or better than they were in Oracle, and to tune all the process while doing this. From the developer's perspective, the CDC part is quite transparent. It's just about data migration. What is, of course, potentially non-transparent to the developers is the number of changes you're requiring for your application.
One question about the final size of the database concerning Postgres and Oracle. For instance, we have 10 terabytes database in Oracle, and how can one estimate the final size of the Postgres database? Are there any methods or technologies?
I cannot say there's a consistent technique for estimating this because it depends a lot of the data. The only way is maybe to take a sample and test it, right? Or take freeze the Oracle database, like actually do the first part of the CDC, take an initial data load, move the data in a frozen state. Of course, that data is to be discarded later, but at least you will see how it imports. Normally, numbers are similar. Sometimes the database in Postgres occupies less, sometimes it occupies more. But expect something in the same order of magnitude.
So the default estimation is the same, yeah?
Yeah, more or less,
the default
yes.
one.
Yes.
Thank you.
You also need to take into account bloat in Postgres. Once you start doing changes in Postgres, you may accumulate some bloat, and actually the data may grow more than Oracle. Because Oracle does not accumulate bloat because it works by a different mechanism.
I have one question about CDC. What approach do you use personally? Well, I mean, do you write your own application which extracts ready logs and deliver it to Postgres? I ask it because I heard about that Enterprise DB has such product, and it's a Java application. What can you say about that? Thank you.
Yes. So as I mentioned before, there are several tools to do this. One is GoldenGate. The others I mentioned. Also, yes, you're right that Enterprise DB has a similar tool for doing this. And most of the tools that are made by Enterprise DB are written in Java. I don't know in details the Enterprise DB tool, but it's typically used only when you're going to migrate to an EDB server anyway, right? So I don't know the scenario about using EDB for a migration to vanilla Postgres. Could be interesting to know. My goal, of course, is to have a very specific tool for Oracle to vanilla Postgres migrations. Yep.
Thank you. My question is, do you have any unsuccessful case of Oracle to Postgres migration in your practice?
Sorry, I didn't hear well. Can you say it again?
Do you have any unsuccessful case?
Unsuccessful.
Oracle to Postgres migration, yeah, in your practice?
No. I mean, when we do one migration, we fight until the end, and we always find a way out. The only thing I may qualify as unsuccessful was this time that we tried to use this software called dbvisit, and didn't work for us after significant effort. So at the end of the road, the solution was either go with GoldenGate or do an offline migration. And in this case, the customer opted for offline migration, taking more downtime than initially, according to their SLA, right? If you want to call it that as unsuccessful, definitely was not the most successful one from that perspective, even though finally the offline migration took place and the offline downtime was exactly as planned and as benchmarked before. And even though it was not targeting the customer's initial timeline, it matches exactly the newly accepted one.
I have another question with respect to the performance. So the original sale factor for Oracle was, of course, performance. And given your experience for the same hardware, how do we compare the performance on a normal benchmark of Oracle versus Postgres?
Okay, so first of all, I cannot talk about Oracle performance because 0.7, 0.2, 0.3, 0.4, 0.5 letter C of the Oracle license, or whatever it is exactly at that point, explicitly prohibits to disclose results of Oracle performance. Okay, so I am prohibited by their license to speak about Oracle performance. Having said this, I also don't have real numbers because all of the systems, they typically use whatever they have for the Oracle database running in production, maybe for 3, 4, 5 years. Basically, oldish hardware. And they're migrating to a new shiny environment, super new hardware, cloud environments, whatever, right? So they're not going to put the same hardware to migrate to Postgres, in which case you could compare very well. It's always a slightly better environment. Performance has been always very good. If you know how to tune Postgres, if you check the proper indexes that need to be created, if you do a long testing period time, don't rush to do a migration, never. That will never work well, right? Test a lot. Find load testing tools from the customer that they will test, not PGBench, test what they are using in reality, right? Or even write a specific benchmark for this customer, right? Based on what they use, capture their traffic, capture what they're doing, and reproduce that. And if you look at those queries, you install in Postgres pgstat statements, you're that testing. You capture the performance in Postgres, and you tune it and tune it and tune it, you'll get to a decent point, right? And because you're even also typically running on better hardware, the result is that typically you're gaining performance after the Oracle to Postgres migration. Now, even if it wouldn't be the case, let's say, okay, no, I'm getting a 20% drop in performance. with the money you're saving for the licenses, okay, you know, bring a 40% more expensive server. And you'll still get a 20% extra performance, or 15, or whatever, right? So, but normally, yes, you end up getting better performance, but also because you're getting better machines. There was some attempts to do Postgres TPC numbers, but TPC, I don't think it's necessarily a good proxy for Oracle to Postgres comparison, because TPC, first of all, is super tailored for some vendors, and Oracle is pushing a lot for TPC, and they're using very specific high-end hardware that is not representative of the servers you may have, right? So most TPC benchmark are running on servers that cost $500,000. Not everybody runs databases on such a hardware, right? So the numbers you'll see there may not be different. And there's not been a lot of effort in any way in publishing TPC numbers for Postgres because it's very expensive.
Well, and one more question. I have visited recently some Oracle studies, and there the teacher said that the current level of Postgres functionality is on the level of Oracle 8 or some near this version. My question is it true or it's a myth?
Well, it is opinionated, right? I mean, some people may say something, some people may say other things. It really depends. In general, my take is that that's much more than a myth than anything else. In general, I would say that Postgres is at the level of Oracle, and in many areas, significantly much more advanced than Oracle. Much more. In other, less. What matters is what it matters for you. Are you using this functionality or you're not using it? Because if we count with all the functionalities that Oracle has, that Postgres hasn't, but that are very rarely used, then we may agree that it's much more advanced. But who cares if you have something that you're not using? That's what really matters. So it's a lot about opinion. In general, I would say you're, after switching to Postgres, everybody is extremely happy. They miss almost nothing from Oracle. They see augmented flexibility, augmented easiness. It's much easier to operate. It's simpler. You can install it very easily on other environments. Postgres is very lightweight. It's very easy to install Postgres, apt-get install Postgres. You have Postgres in your laptop. Docker pull Postgres. Have any of you tried to build the Docker image of Oracle? No? Okay, will take you a whole day, probably. And generates Postgres Docker image is 200 megabytes. Oracle Docker image is 13 gigabytes. It's different worlds. So Postgres is so much more easier, so much more lean, more convenient, more simple, yet has a lot of features. And the point is, do you want to pay for the difference, even if you need those features, right? Because the difference in price is so much bigger. Performance is not a question. You can always almost always make it better in Postgres because you can pay much more server for the same price, right? Unless you hit the limits of scaling of a single server. Below that, performance will be always better if you tune appropriately. So then it's just a matter of whether you're using transparent data encryption, and that is a yes or yes. Okay, then yes, Oracle is better. Pay for it. Microphone? Or if not, I'll repeat the question.
Is there an analog of AWRs in Postgres?
That's a very good question. Basically, I don't know of a tool which gives you as many insights as AWR for Postgres. Yeah. I still believe in general that Postgres ecosystem has a lot of gaps and a lot of improvement. There's a tool called POWA that will give you some performance insights, POWA. POWA. There is the classical Unix tools, there is SAR, there is monitoring in general, monitoring tools that give you also some CPU usage, I/O. For example, in our company we built a tool called PGIO, which is open source, it's on GitLab, and basically drills down the I/O caused by Postgres and tells you which part of Postgres is doing the I/O. If it's a checkpoint, if it's a background worker, if it's a vacuum, it is queries, you know, so to understand who's causing I/O within Postgres. There's many functionalities to be developed as part of the Postgres ecosystem. All right, so I'll continue with the last part of the tutorial today, the talk. Again, if there's any question, just raise a hand or I'll continue at the end. We'll have, I guess, a little bit of extra time for more questions. Yes, I think we will have. So this is just very quickly, because it actually summarizes much of what I've been talking about today. Real use case, how we help BlackBerry, or specifically BBM, the BlackBerry Messenger application, to migrate from Oracle to Postgres. Think about more than 150 million users migrated from Oracle to Postgres without downtime. Actually, this is a summary and some insights from the Postgres and database land of a bigger talk that was presented by BBM CTO Mohan Krishnam in Google Cloud Next last year. It's a very good talk. It gives you very impressive details about how they did the networking part, which was on them, of course, and some other topics. I recommend you to watch this video also. So, first of all, just very quickly, what is BBM? Because I don't know how many of you use here BBM, BlackBerry Messenger application. Yeah, I guess you use Telegram mostly, right? Whatever. So, the BBM is not what we used to understand by BlackBerry. It is not what you would say your father's messenger, or I would say also my messenger already, whatever, it doesn't matter. It is not an old thing. It is a brand new application, very modern, that supports a lot of advanced capabilities, supports even payments, group messaging. It is more similar to WeChat than what it could be a WhatsApp or other tools like this. And has more than 150 million users, mostly in Asia. Actually, BlackBerry became very famous in Indonesia because by the time the cellular networks were not working very well, and BlackBerry was working very well under such a scenario, so everybody got a BlackBerry and they didn't leave that. So it's still a world dominated by BlackBerry. They have around 75, 80 million users there. I don't know exact numbers. But anyway, now right now it's an application available in still BlackBerry, but also on Android and iOS. If you want to try it, give it a try. It's interesting. Now, for you to understand the size of this migration, they migrated the whole infrastructure from on-premise to the cloud. So not even involving the database part, like everything. This involved 6,000 servers. It was a project that took almost 2 years. The database part was only 6 to 9 months, but it took 6,000 servers. And they were migrating from on-premise on Canada to GCP, to Google Cloud Platform on Asia region, in Indonesia. That basically is a very long distance. Very long distance. And the database part, the Oracle part, was not about the messaging, because the messaging is basically managed by Cassandra. But what was contained within the Oracle database was the user authentication. So it was critical for absolutely any operation within this. Remember, this application is like a platform. It has like sub-applications contained within, including the messaging part. Everything needs to go back to the Oracle database now, to the Postgres database, to authenticate the user, to create tokens for authorization of applications, everything. Relied on Oracle, now everything relies on Postgres. So it was very critical to the infrastructure, to the service, absolutely critical. So what were their requirements to us? They were very strict requirements. First of all, obviously, almost no downtime. You cannot ask 150 million users to wait for 8 hours or 10 hours. That was more or less the estimation of an offline migration to be without messaging for 8 hours. They will lose a significant part of those users, right? And we need to move data over the Pacific with a link that had almost a quarter of a second of latency, which is very high. Pacific is very large, right? So also, this is required to have a very long testing period. You need to test your application, make sure it really works. Again, you cannot disappoint 150 million users after the migration and say, oh, you know, sorry, there was a bug there. We'll fix it tomorrow. So you need to test it and test it with real data, with real traffic, no, you know, synthetic testing. And what was very important is to set up the whole Postgres architecture. It is not enough to say, you know, I'm going to install Postgres and apt-get install Postgres. Yeah, here you have, migrate. No, you need configuration tuning. You need security. You need high availability. You need backups. You need monitoring. You need disaster recovery. You need logging. You need query performance monitoring. You need log processing. This is the whole set of things you may require. You need operating system tuning, file system tuning. You need a lot of things to do around running a Postgres in production. It's not as apt-get install Postgres, right? This is what we call a Postgres stack, and it's very complicated. It involves a lot of effort to build a whole Postgres stack. If you want to run Postgres in a heavy production environment, you need to do all these things. It takes a lot of time, a lot of effort. So, the migration steps, we're already familiar with this. Nothing changed from what I discussed before. We did the DDL migration, the first step. There was a bit of stored procedures. There were not so many in these cases, and just basically involved code around triggers. Many of that part of that code was actually just calling a sequence to update a field. This is something in Postgres you don't require a trigger, and don't do that with a trigger. You can do that with a default value as part of the column definition. So, you know, very simple, that part, fortunately for this project. The challenging part of this project is the data migration part. Also to build this architecture on GCP, this whole stack that I was mentioning before, how to build all this in GCP, because they were not wanting to use the managed service that Google is offering for Postgres. It has several limitations and was not even GA by this time. It was beta, and they didn't want to use that. And so how do we do the live migration or no downtime with the live migration, with the CDC technique that I mentioned to you? And it was key to have a rollback mechanism. And it was almost exercised, but not because of the database part. I'll explain you. So, how the DDL migration happened? It was very easy also at this part of this project because they were using Hibernate. The application was developed in Java. They were using Hibernate, and Hibernate there's some things I don't like about Hibernate, but the only thing that I like is that you can say, oh, now you're running on Postgres, and the queries it will generate will be compatible with Postgres. So the application required few changes. There's still, of course, some changes that I need to do. There's always manual queries being run because, you know, the ORM breaks the abstraction, and you require those. But in general, the changes in the application were not so heavy. So Oracle to PG was used for the DDL migration. We didn't want to Hibernate to do this. And now there was a lot of heavy changes being involved here, both to tune some of the tables in order to tune for the data types, remove duplicated indexes, remove unnecessary indexes, to tune the performance for numeric data types, to inspect the data in the source database, and this was a lot of back and forth process. It was even necessary to use this chance to partition the data. So also data partitioning was brought into the process, and so the DDL changes were more or less significant. And the timestamps always, and calendars, and hard-coded values, and time zones, they create a lot of problems. So this was the difficult part. Also, to change permissions. They were using separate applications with separate users. And in Oracle, user is a schema. In Postgres, schemas and users are not necessarily related. And namespace schemas are just namespaces, which groups objects. You can assign different permissions. So this requires also adjustment. It is, again, not a one-to-one mapping, so you need to do some work to lay out things according to good security practices and the way you want them to be. As I mentioned before, also some constraints were turned from triggers into column constraints. For example, if you want to update one value by incrementing the sequence, there's something that it was done with an Oracle trigger. In Postgres, you can do part of the column definition. You can say, this column is an integer, not null or whatever you want, default, next val, and the name of a sequence, and that will insert automatically that number. You don't need to capture a trigger, capture the row, update that field, call the sequence, update the field, and store it. It's not necessary. You can do that too, but it's not necessary. We did a lot of cleanup. There was a lot of indexes that were not needed, that were duplicated, or that Oracle was using them, but tests shown that Postgres was not using them, and it was pointless to have those indexes. Because unused indexes hit insert or write performance in general, right? So, also for the CDC part, I mentioned briefly before, you always need either a primary key for the table or a unique way of identifying rows. Because as of the CDC part, doing an insert always works, but doing a delete or an update typically targets a single row. And you can use the row ID in Oracle to do this. You need a unique identifier of that row that has row data as that key. So in other words, you typically need a primary key. And not all tables have a primary key. And that is fine, except for the migration process. So you end up requiring a primary key for every table. And that also implied some changes. And as I mentioned, this chance was also used for partitioning. The original table had around 2 billion rows. And that is a big already enough number to split the table into Postgres. So in order to avoid potential, I mean, Postgres can run a table with 2 billion entries. That's okay, but it's better if you partition the table into smaller tables. The key here is that, strictly speaking, in a CDC, because CDC is based on logical replication, because you're replicating SQL statements, it's not strictly necessary to have exactly the same schema on the source and the same schema on the destination. What it matters is that they are compatible. I could have extra columns on the destination on the tables as long as they have default values or they are nullable, because an insert will work. The same with this. If the data is not partitioned into the source but is partitioned in the destination, as long as Postgres will insert into the correct partition transparently, and you can do that with triggers or with, Postgres 10 didn't exist by then, or 11, then it works. So we also did that partitioning. So, about the architecture in GCP, I told you that this part was also significant because you need to build this whole architecture, this whole stack on GCP, and involves all these tools that I mentioned, the monitoring, the backup, disaster recovery, high availability, all that. So how you do that? Well, we used a combination of tools, basically Ansible for automation, Vagrant for testing in local environments, and the gcloud API. So all the deployment was fully automated. You can run a script and the whole servers, machines, Patronic clusters, everything was configured automatically. And then about the tools, the config was heavily tuned, and also pointing again to this talk that I have online, Postgres Configuration for Humans, if you want to know more about Postgres tuning. And then we use PG Bouncer for connection pooling, Patronic for high availability, and Wally for backups and disaster recovery. I'm not going to get into the details, and maybe you cannot see all the diagram from there, but this is what the architecture looks like on GCP. So there were 2 clusters on different availability zones within the same region. They have the Postgres themselves with the primary and several secondaries, cascading, replicating to the other zone on the region. In parallel, those were all archiving, and each region has a console cluster to support for the consistent data store that Patroni requires for these. It is a quite complex architecture. I don't want to get into the details right now, but just for you to have an overview. And this is obviously just the part of the Oracle architecture, because then, sorry, the Postgres architecture, because there's also the architecture related to the migration part, which is even more complicated, right? Because for this migration, we had to build a Postgres cluster on-premise, because the CDC directly over the long-distance channel was not very performant. So we actually did the migration of the CDC to a local cluster, which we set up with all the goodies, with all the high availability, with the console cluster, and then use regular, and from there use regular Postgres streaming replication, asynchronous Postgres streaming replication, to replicate over the Pacific to the real Postgres cluster on GCP, which is here. So you can imagine this was quite involved. It was also in parallel wall archiving, shipping over to the Pacific also, to make sure that even if the streaming fails, the Postgres will catch up with the archiving. And finally, just to give you some numbers of how the cutover went. Cutover is when you stop the traffic in Oracle and then wait for the replication to finish, and then turn on the data in Postgres. The live migration, the CDC, which was, by the way, I didn't mention, but it was done with GoldenGate, was running for 2 months. 2 whole months making sure that it works, that all the data is being replicated, and that it was testing and performance tested on the destination. It was restarted frequently to also to test it, and because some testing was writing data on the destination and was corrupting it, but it doesn't matter, you just restart it, wait for a couple of days to synchronize, and then you can play again. Actually, it was less than 1 day. And the cutover was fully scripted. There was a runbook of more than 100 commands, of course, not only for the database, but also for the other parts of the application. And was tested between 3 or 5 times before the final one happened, like in dry run tests. And finally, the data contributed downtime for the application was around 5 minutes. It could have been actually less, but you know, there was some extra operations being performed there. And BBM decided to take an extra 40 minutes to perform an extra data check to make sure that no row was missing. And this was also heavily parallelized, custom-made application to check that exactly the same data in Postgres, in Oracle, was in Postgres. This check was optional because data was okay, the check was successful. You could have avoided that. But anyway, it was 5 or 45 minutes downtime, however you want to say it. And well, that's basically it. Any more questions? No? Well, then I guess we are more or less in time, and maybe someone is hungry here, so thank you very much.